Have you ever looked up at the night sky and just wondered? Not just where it all came from, but where it's all going. Well, today we're going to dive into that ultimate question.
I mean, really think about it. How does the universe, all of this, everything we know and everything we can't even imagine, how does it all end? It's a question that feels almost too big to ask. But for the first time in history, we actually have the tools to try and find an answer.
You know, for thousands and thousands of years, this was a question for myths, for religion, for philosophy. It was a story you told, a matter of belief, not something you could solve with a calculator.
But wow, has that changed? Today, this is a question for physics. We have telescopes that can see nearly to the beginning of time itself, and theories that can describe reality. We can actually hunt for clues about the end of everything. It's a real scientific investigation.
So it turns out the fate of our entire universe really boils down to one thing: a massive cosmic tug-of-war. There are two forces pulling in opposite directions, and whoever wins, well, that determines everything.
Okay, so on one side of the rope, you've got gravity. We all know gravity. It's the force that pulls things together. It makes stars, it makes galaxies. It's always trying to slow things down and pull everything inward. But on the other side, there's this really mysterious thing called dark energy. It's like a pressure built into space itself, and it's pushing everything apart, trying to speed the expansion up. So the big question is, who wins this fight?
In this cosmic struggle, it doesn't just decide if the universe expands forever. It literally dictates the actual shape, the geometry of all of space-time. And there are really only three ways it can go, each with a completely different destiny.
First, you could have a closed universe. The easiest way to think about this is like the surface of a sphere. If you and a friend start walking in parallel lines, you'd eventually crash into each other on the other side. In this version, there's so much stuff in the universe that gravity wins the tug-of-war, stops the expansion, and eventually pulls it all back in.
Then there's the open universe. This one's kind of shaped like a saddle. Here, if you and your friend walk in parallel lines, you just drift farther and farther apart forever. In this scenario, dark energy wins big time. Gravity just isn't strong enough, and the universe expands for all eternity.
And finally, we have the flat universe. This is the Goldilocks scenario where everything is just right. It's like a giant flat sheet of paper. Parallel lines stay parallel forever. Here, the forces of gravity and expansion are almost perfectly balanced. Now, what's fascinating is that our best measurements tell us our universe is extremely close to being perfectly flat. Remember that, because it's a really important clue.
All right, so with the battlefield set and the cosmic forces in place, cosmologists have basically got three main suspects for how this whole thing could end. Let's open up the case files. Okay, the current frontrunner, the one most scientists would probably bet on, is called the Big Freeze. And it's not some big dramatic explosion. It's a slow, quiet fade to nothing. Over trillions of years, the last stars will flicker out. Then, over timescales that are just impossible to imagine, even black holes will evaporate away. And what's left? Just a cold, dark, empty void getting closer and closer to absolute zero forever.
Suspect number 2 is way more violent. It's called the Big Rip. This could happen if dark energy isn't constant but actually gets stronger over time. The push would get so powerful that it would first tear galaxy clusters apart, then individual galaxies, then solar systems, and eventually it would rip apart stars, planets, and even the atoms inside you before shredding the very fabric of space-time itself. A pretty brutal end.
And that brings us to our third and final suspect, the Big Crunch. It's basically the Big Bang in reverse. Gravity wins the war, the expansion of the universe slows down, stops, and then it all comes crashing back in on itself, getting hotter and denser until it collapses into a single point. Now, for a long time, most scientists thought this was the least likely option. But there's been a twist in the story.
Yeah, just when it seemed like the Big Freeze was the obvious answer, some theoretical physicists have found a really good reason to take another look at the Big Crunch. And it all comes down to a really powerful idea, making sure the laws of physics don't, well, break.
Okay, I know this quote looks super technical, but stick with me, the idea behind it is pretty straightforward. There's a fundamental rule in physics called the ANEC. You can think of it as a basic common sense rule for the universe that stops really weird stuff from happening, like having negative energy. And what these researchers are arguing is that for the math to work out cleanly without breaking that rule, the universe has to be closed. They're saying flat and open universes just can't exist without violating this really important principle.
And these graphs show exactly why. Look at the chart on the left for a flat universe. To make the model work, you need what's called phantom energy, which basically means you have to break that A-N-Eck rule. It's something most physicists think is impossible. But now look at the graph on the right for a closed universe. Everything works perfectly with normal standard physics. No rules are broken. From a theoretical point of view, it's just a much cleaner, more elegant solution. It works.
And here's the kicker. This isn't just some abstract theoretical idea. By following this logic, this new model makes a testable prediction. It suggests the expansion of the universe could stop and reverse, leading to a big crunch in about 20 billion years. All of a sudden, the end of the universe doesn't seem quite so far away, does it?
So, where does that leave us? On one hand, we have the leading theory, the Big Freeze, which is based on everything we can see and measure. On the other hand, we have this powerful challenger, the Big Crunch, which is based on how the laws of physics should work. The final chapter of the cosmos is still very much unwritten.
The final verdict really hangs on solving some of the biggest mysteries out there. I mean, what even is dark energy? Is its strength constant, or does it change? And while our universe looks flat, even a tiny, tiny amount of curvature, so small we can't detect it yet, would be enough to tip the scales and decide our fate between a freeze or a crunch.
And so we kind of come full circle, back to a deep, almost philosophical question, but now it's one that physics is trying to answer. The universe had a beginning, it just feels like a story that should have an end. But whether that end comes as a slow fade, a violent rip, or a cosmic collapse, well, that's the final mystery we're all trying to solve.